Solve the following equation. 4x to the fourth power minus 8x squared plus 3 equals 0. In order to solve this, uh, notice that it's very similar to a quadratic, but it's not quite a quadratic because we would need the largest exponent to be 2 instead of 4. But we could probably take care of that. If we were to let a new variable u be this variable term here in the center, so let it be x squared. And then notice that if I square both sides of this equation, I get u squared equals x squared squared. When you raise one exponent to another, you can simplify that by multiplying. So that means I can replace x to the fourth with u squared, so this would be 4u squared minus 8u plus 3 equals 0. And there's a possibility here that this could factor. Maybe I need to use the quadratic formula. I'm not really certain at this point, but I tend to try factoring first. And to factor, what I would do is try and come up with two things that would multiply to the leading term, 4u squared. So 2u and 2u would multiply to 4u squared. Then I need two things that multiply to the constant, so that would be 1 and 3. Now, what I also need is the middle term to work out, which means I need to multiply these two values, so 2u times 1 is 2u, and these two. So 3 times 2u would be 6u. Alright, now, I need them to add to negative 8u, and if they were both negative, that would actually work out. So if both of these are negative, let's make sure everything checks out at this point. So negative 1 times negative 3 would give me positive 3. The middle term works out to negative 8u, and then the first term, the leading term that is, 2u times 2u is 4u squared. Okay, that's great. Now, the next thing that I would need to do is take each of these, so 2u minus 1, and set them to 0. And 2u minus 3 equals 0. Now, these are linear in the variable u, so I just solve them by getting u by itself. So 2u equals 1, or u equals 1/2. And in this case, 2u equals 3, or u equals 3/2. All right, now the last step is to go back to the original variable. So right now I have the equation solved for the variable u, but I need to go back to x. And this statement right here shows me how to do that. So instead of saying u equals 1/2, I'm going to say x squared equals 1/2. And likewise, x squared equals 3/2. All right, now to get x by itself, what I need to do is take the square root of both sides of this equation. But when I take the square root of a variable, I need to make sure I consider the plus or minus case on the constant. So this is going to be x equals the plus or minus square root of 1/2. And you can do the square root of a fraction separately by the numerator and denominator. So the square root of 1 is just 1, so I can leave that as plus or minus 1 over the square root of 2. And I don't want to leave a radical in the denominator, so what I will do next is just rationalize that by multiplying top and bottom by the square root of 2. So this becomes x equals plus or minus 1 times the square root of 2 is the square root of 2, and then the square root of 2 times the square root of 2 is 2. Now the other case here, x squared equals 3/2. Similar situation, I would take the square root of both sides. So that would be x equals the plus or minus square root of 3 over the square root of 2, which I would need to rationalize that denominator as well. So I'll multiply top and bottom by the radical that's in the denominator. So x equals the square root of 3 times the square root of 2 gives me the square root of 6. Square root of 2 times the square root of 2 would be the square root of 4, which is 2, and that's a whole number, which is fine for the denominator.